We've grown accustomed to blindly trusting the weather apps on our smartphones. Modern meteorology uses multi-billion-dollar satellites, space stations, and powerful supercomputers. But we still regularly get caught in sudden downpours without an umbrella. What if I told you right now that everything you believed about weather forecasting is a lie? Just imagine, for centuries, the indigenous peoples of the Great Plains survived in one of the harshest and most unpredictable climates on the planet. A sudden tornado or a deadly blizzard could wipe out an entire camp in a matter of minutes. And yet, the Lakota people managed without complex meteorological instruments, using nature itself to make phenomenally accurate forecasts. Their knowledge allowed them to predict the approach of a destructive storm with frightening accuracy days before the first dark cloud appeared on the horizon. And no, it wasn't magic or just shamanic myths. These ancient methods were based on a profound intuitive understanding of atmospheric physics, microscopic changes in air pressure and humidity that modern people simply aren't capable of detecting. Be sure to watch this video all the way to the very last second, because today we're going to decode this ancient weather code. You'll learn how invisible air vibrations and subtle clues from nature saved entire settlements from the fury of the elements. And closer to the middle of the video, I'll tell you about a living biological barometer used by Native Americans that predicted storms more accurately than modern radar. Ready to be amazed? Then hit that like button, make sure you're subscribed to the channel, and let's dive into the mysteries of the Great Plains. Are you ready to learn the truth about how herds reacted to invisible atmospheric changes? For the Lakota people, observing the horizon always began with assessing the general movement of large herds on the plains. Large mammals have a unique inner ear structure that instantly reacts to a sudden drop in barometric pressure. Long before the first dark clouds appear, the air begins to rapidly lose its density due to thermodynamic shifts. This physical change causes discomfort in the hearing organs, forcing herds to huddle into tight groups for protection. For Native Americans, this behavior served as the first reliable sign of an approaching large-scale cyclone. Lakota hunters and trackers noticed the slightest changes in the usual rhythm of migration across vast expanses. If a herd suddenly stopped moving and lay down on the ground, it meant a severe storm was approaching soon. The ground served as a kind of conductor, transmitting low-frequency vibrations from distant rumblings of thunder directly to the bodies of the resting giants. In this position, the body received the maximum amount of information about the approaching storm thanks to the vast area of contact with the ground. Scientists today confirm that a drop in pressure directly affects the receptors of the vestibular system, dictating an energy conservation strategy. The vast expanses from the Missouri to the Rocky Mountains had no natural barriers to slow the wind. Therefore, early warning provided the necessary time to prepare strategic reserves of heavy wood fuel. In winter, a sudden blizzard could cut off a camp for weeks, making it impossible to forage for food. Knowing the exact time the snowfall would begin allowed hunters to return with their catch before visibility dropped to zero. The entire logistics of a nomadic people were built on this delicate and infallible reading of barometric changes in the environment. Physiological changes in the body during a drop in pressure also reduce overall physical activity. Conserving energy became a priority biological task in the face of a sudden and inevitable cold snap. The Lakota adopted this adaptation tactic, reducing their activity and focusing on retaining heat inside their dwellings. Inside the teepee, an optimal microclimate was maintained with the help of small fires that burned steadily and evenly. The smoke from these fires served as an additional, no less important indicator of the state of the heavy atmosphere. When atmospheric pressure dropped rapidly, the density of the surrounding cold air decreased. The smoke from the hearth could no longer rise high into the air and began to spread heavily across the dry ground. This second sign confirmed the accuracy of the initial observations of the behavior of the inhabitants of the vast plains. A comprehensive approach to analyzing the environment virtually eliminated the possibility of a fatal error in calculations. Survival on the Great Plains did not tolerate a superficial or careless attitude toward the strict laws of nature. Heat flows within the Indian camp itself also radically altered their behavior before the storm. Cold air accumulating in the low-lying areas pushed the warmer, lighter masses high up. This created specific sound vortices around the conical structures of the closely spaced dwellings. The teepee's shape was ideally suited to dissipate such extreme wind loads from all sides. The ancestors' knowledge allowed them to transform the structure's geometry into a perfect tool for battling a violent hurricane. These methods demonstrate the incredible level of physical adaptation of Native Americans to the harsh conditions of the continent. Their science of survival was based on rigorous empirical analysis, free from mysticism, superstition, and empty speculation. Every step, every vital decision was made solely on the basis of indisputable facts proven over centuries. I'd be very interested to hear your perspective on such unusual natural barometers. What do you think about these forecasting methods? Please share your thoughts in the comments. Be sure to subscribe to the channel to continue discovering new facets of forgotten history. I discovered this by chance while studying the diaries of the very first European explorers of the harsh Great Plains. For the Lakota, the color of the evening sky served as the most accurate visual indicator of impending changes in regional weather. A red sunset occurs due to the complex physical effect of Rayleigh scattering of sunlight in a dense atmosphere. Dust and moisture particles absorb the short wavelengths of the blue spectrum, allowing only the long red rays to pass through. To an experienced observer, this signaled the presence of a dry, stable, and dense air mass to the west. The density of dry dust particles in the air also greatly influenced the intensity of all the hues in the sky. Strong westerly winds carried tons of parched earth hundreds of kilometers from the Native American settlement. This gigantic dust filter altered the refraction of light, warning of the approach of powerful air currents. The trackers assessed not only the color itself, but also the rate at which the hues changed on the horizon during sunset. A rapid fading of the colors indicated a sharp drop in temperature in the upper, invisible layers of the atmosphere. The halo around the setting sun often had a characteristic yellowish or whitish tint due to ice crystals. Cirrus clouds, composed of these microscopic crystals, always precede a warm, moist front. Their appearance at an unusually high altitude signaled that a severe storm would begin in a couple of days. Experienced Lakota observers could unerringly distinguish high-altitude ice clouds from ordinary low-level water vapor. This visual difference was crucial for accurately calculating the time remaining before the onset of destructive weather. Observation of the boundless sky was always conducted from high ground, free of trees and natural obstacles. The hills of the Great Plains served as excellent natural observatories for surveying the horizon in all 360 degrees. Air humidity was unerringly determined by the degree of blurring of the sun's disk at the moment it touched the earth. A sharp outline signaled dry air, while blurred edges indicated an abnormally high concentration of accumulated moisture. All this complex visual information was quickly analyzed and transformed into an accurate 3-day weather forecast. The understanding of the laws of optical physics without knowledge of the scientific terms themselves amazes modern meteorological researchers. Centuries of experience were passed down by word of mouth, forming an incredibly reliable database of accurate meteorological data. Each new generation added its own personal observations, carefully refining the local characteristics of the complex climate. Mountains and deep rivers made their own adjustments to the movement of air masses, altering the classic aerodynamic picture. The Lakota always took these subtle geographical nuances into account when interpreting the color of the evening horizon. Comparing the hues of the evening sky with the direction of the surface wind provided a complete picture of impending atmospheric events. A light westerly breeze at sunset fully confirmed the stability of the established powerful anticyclone. A sudden easterly gust against a backdrop of heavy crimson clouds disrupted the usual pattern, signaling a head-on collision of fronts. At such critical moments, the vast camp was instantly put on maximum, heightened alert. Nature never forgave mistakes made by those who ignored its clear and distinct visual warnings. These ancient methods prove that humans are capable of synchronizing with the planet on the deepest, most physical level. Analyzing the most complex light spectra became a routine task for people who lived in absolute harmony with the Earth. Do you think modern city dwellers are capable of sensing changes in atmospheric density with the same subtlety? Share your thoughts on this in the comments below this video. In the next chapter, you'll learn how the smell of the air warned indigenous peoples of deadly natural dangers. The secret that people pay thousands for lies in the unique, hidden properties of the human sense of smell. Before a heavy snowfall or thunderstorm, the chemical composition of the air changes dramatically due to powerful electrical discharges. Hurricane-force winds in the upper atmosphere collide with ice crystals, generating a massive amount of static electricity. These invisible micro-discharges split oxygen molecules, which then combine to form heavy, triatomic ozone. The Lakota were well acquainted with this sharp, crystal-fresh scent that appears long before the first heavy rains. Downward air currents from massive thunderclouds rapidly carry this ozone to the Earth's surface. The human nose is capable of detecting the distinctive smell of ozone even in the most microscopic, minimal concentrations. For the Native Americans of the Great Plains, this scent served as an invisible harbinger of an approaching storm front. Their keen sense of smell, honed by life in the wilderness, allowed them to detect it from dozens of kilometers away from the storm's epicenter. The richer and heavier the scent, the closer and more destructive the approaching natural disaster was expected to be. The second important chemical marker of approaching bad weather was geosmin, a special substance released by soil bacteria. When atmospheric pressure drops sharply and humidity rises, the microscopic spores of these bacteria are pushed into the air. Moisture causes the porous surface of the dry earth to literally exhale the underground gases trapped inside. This earthy, incredibly thick smell foreshadowed prolonged, lingering rains or heavy wet snow. The indigenous people of the plains unerringly recognized geosmin long before it was officially discovered by modern chemists. Air masses acted as a giant, invisible conveyor of information about the state of the environment. The speed at which all odors spread depended directly on the current density and temperature of the troposphere above the plains. In cold air, scents spread much more slowly but become denser, more concentrated, and sharper. In a warm environment, odors dissipate very quickly, mixing with vapors from the intensely heated ground. Understanding this physical difference helped the Native Americans determine the nature of an approaching thermodynamic front with the utmost precision. Even the familiar smoke from campfires changed its aromatic properties when barometric pressure dropped sharply. Excess moisture in the air bound the light soot particles, making the smell of burning heavier, more suffocating, and more acrid. Resinous firewood emitted more black soot, which settled in a thick layer on the skins of the conical teepees. The inhabitants of the vast camp instantly detected these chemical changes, requiring no additional external confirmation. Their sensory system functioned as a single, flawlessly calibrated, and highly accurate meteorological gas analyzer. Meteorologists today are genuinely amazed at how the human brain has adapted to analyzing such complex chemical data. For the Lakota, this was a fundamental matter of daily survival in the harsh, unforgiving climatic realities of the prairies. They did not divide nature into separate elements, perceiving smells, the color of the sky, and the wind as a single, inseparable whole. A comprehensive analysis of these numerous factors always yielded a predictive picture of unsurpassed, absolute accuracy. The sense of smell served as one of the most ancient and reliable tools in this rich arsenal of knowledge about nature. The ability to analyze the chemical composition of the atmosphere in detail without laboratory equipment proves the perfection of the human organism. These unique skills convincingly demonstrate the Native Americans' highest level of integration into the North American ecosystem. The loss of such ancient knowledge in today's modern, technology-driven world makes us more vulnerable to nature's sudden whims. If you enjoyed this deep dive into forgotten survival secrets, please like this video. Your support helps us create even more high-quality, informative, and interesting historical content on a regular basis. The hidden truth that everyone keeps quiet about is that the laws of aerodynamics were used by humans long before the invention of airplanes. The Lakota closely observed the gliding altitude of birds over the endless expanses of the plains. Before severe storms hit, atmospheric pressure drops sharply, making the air much less dense. Because of this rarity of the atmosphere, it becomes physically much more difficult to generate the necessary aerodynamic lift. Therefore, the winged creatures of the Great Steppes are forced to descend into the lower, denser layers of the atmosphere closer to the ground. The Earth, heated by the scorching sun, constantly generates powerful rising thermal currents that, in clear weather, rise for kilometers. Creatures soaring high in the sky use these warm columns of air for long flights without wasting precious energy. When a cold front approaches the region, it blocks these updrafts, forcing the warm air tightly against the ground. The complete absence of invisible thermal support forces the winged inhabitants to fly very low over the grassy surface. For an observant person, this has always served as a sure, indisputable sign of a change in the general barometric conditions. Experienced tribal scouts also paid special attention to the direction of mass horizontal movements in the air. Movement across the vector of the usual, prevailing winds signaled a desperate attempt to escape an area of sharp barometric pressure changes. The formation of unnaturally dense groups instead of solitary flights indicated a rise in static electrical tension in the air. The airspace transformed into a complex, multi-layered map of isobars, which the Indians could read without any instruments. Their predictive knowledge was based on pure biomechanics and centuries of observations of natural aerodynamics. The unforgiving physics of the atmosphere dictated its extremely strict conditions for absolutely all inhabitants of the vast continent. Dense, icy air, aggressively intruding upon the heated plains, created a powerful, invisible thermodynamic wall. The violent collision of air masses generated strong microstorms right at the boundary of the two invisible fronts. The ability to visualize these invisible high-altitude barriers based on indirect aerodynamic signs was a true art. The Lakota passed this complex art onto young hunters during long, grueling treks across the wild steppe. During the dry and incredibly hot summer months, this method allowed them to predict the arrival of suffocating dust storms with unerring accuracy. A strong updraft, devoid of moisture, carried tons of sand and fine debris high into the stratosphere. The zone of comfortable soaring shifted abnormally high, disappearing into a thick veil of impenetrable, dry earthen haze. The hunters knew full well that soon this overheated air would crash down onto the parched earth as a hurricane-force wind that would knock them off their feet. The camp was hastily packed up in a matter of minutes and urgently moved to sheltered rocky ravines. In winter, this same basic aerodynamic principle worked to predict heavy, multi-day snowfalls. The massive crystallization of moisture in the upper layers changed the density of the air, creating the frightening effect of a leaden, heavy sky. All biological activity in the sky came to a complete standstill, long before the first sparse snowflakes fell to the ground. The silence hanging over the cold, snow-covered steppe was deafening, unsettling, and deeply significant. It served as the very last, silent warning before the onset of a deadly Arctic cold snap lasting several days. The accuracy of these visual observations remains a source of genuine admiration for modern academic climatologists. Have you ever wondered how much we have lost our vital connection to the physical processes taking place around us? In the next chapter, you'll learn how optical atmospheric illusions high in the sky predicted the weather on solid ground. Are you ready to discover the hidden meteorological secrets of the night sky over the Great Plains? Stay tuned for the next chapter to find out how they coped with this dreadful weather. The night sky over North America provided Native Americans with a vast array of vital climatic and meteorological data. The most vivid and unmistakable visual sign of an impending severe weather system was the appearance of a halo around the moon. This incredibly beautiful optical phenomenon is a luminous, perfectly smooth ring surrounding the night sky's luminary. The scientific explanation for this phenomenon is closely linked to the refraction of light in microscopic ice crystals. These ice crystals form en masse in thin cirrus clouds at an altitude of several kilometers above the Earth's surface. Cirrus clouds always precede the arrival of a very active, warm atmospheric front. Warm, moisture-laden air, as it moves toward a region, slowly rises above dense, cold air masses. At this immense altitude, the water vapor freezes instantly, forming perfect, mathematically precise hexagonal ice prisms. When the reflected moonlight passes through this icy suspension, it refracts at a precise angle of 22 degrees. It is this physical angle that forms the visible radius of the luminous halo around the solitary night luminary. The speed at which the halo disappeared from the sky also carried extremely important and urgent meteorological information. If the luminous ring was quickly engulfed by thick clouds, a storm front was approaching at a tremendous, frightening speed. In such a critical situation, the entire camp immediately switched to emergency mode to prepare for the onslaught of the blind forces of nature. People quickly gathered extra dry firewood and reinforced the wooden teepee stakes with massive river stones. A swift, coordinated response to these nocturnal optical signals often saved large settlements from complete destruction. The open geography of the Great Plains facilitated unobstructed, all-around observation of all celestial bodies. The complete absence of artificial light pollution made the night sky an ideal black canvas for projecting atmospheric phenomena. Knowledge of the nature of the halo was transmitted exclusively through oral traditions and rigorous practical training of young warriors. The Native Americans understood perfectly well that the moon itself does not change. Rather, the environment between it and the Earth changes rapidly. This clear understanding of the difference between an object and its optical distortion demonstrates the highest level of abstract thinking. The harsh winter months made halos a particularly frequent and majestic phenomenon in these cold northern latitudes. Extremely low temperatures near the surface of the frozen ground contributed to the formation of ice crystals even in the lower layers. During such frosty periods, enormous pillars of light and the most complex optical illusions adorned the nighttime planescape. The ability to unerringly distinguish a standard pre-storm halo from ordinary frost fog was critically, vitally important. The slightest error in the forecast could cost a hunting party severe frostbite or certain death in the snow-covered steppe. Lakota traditional knowledge clearly demonstrates that nature itself provides all the tools necessary for survival, free of charge. All that is required is patience and the ability to correctly interpret the visual cues it sends every night. The human eye, backed by the hard-won experience of many generations, functioned as a highly accurate natural optical spectrometer. Attention to the smallest details transformed simple plains, nomads into true experts on the dynamics of a complex atmosphere. Studying the night sky was not merely a religious ritual, but a vital, integral part of their safety system. What major pharmaceutical companies hide has long been well known to the ancient warriors of the Great Plains. The human body itself is an incredibly sensitive biological barometer, capable of predicting the weather in advance. Old healed bone fractures and previously injured joints react instantly to the slightest change in atmospheric pressure. Dense air exerts a constant, even pressure on our bodies, keeping all tissues in a certain physiological balance. When a storm rapidly approaches the region, this external atmospheric pressure begins to drop very quickly and sharply. This barometric drop immediately leads to microscopic expansion of the tissues inside the closed, sealed joint capsules. The fluid that lubricates our joints begins to press more strongly on the nerve endings, causing a feeling of aching, heaviness, and discomfort. The hardened Lakota veterans, bearing numerous old battle scars and fused fractures, were the first to sense these hidden changes. Their trained bodies served as absolutely reliable biological indicators of the approaching destructive cyclone. This remarkable physiological phenomenon is now actively studied within the field of biometeorology and is fully and thoroughly scientifically substantiated. The ambient air temperature also played a significant role in these complex internal physiological processes. A sudden piercing cold snap thickened the synovial fluid, making habitual movements stiffer and noticeably more difficult. The combined aggressive effects of cold, high humidity, and low pressure painted an unmistakable internal picture of an impending blizzard. The Native Americans listened incredibly closely to their slightest sensations, fully understanding their vital protective function. The body itself would promptly warn its host of the critical need to find safe shelter and conserve heat. Such a biomechanical reaction is characteristic of absolutely all people, but it was the nomads who paid special, close attention to it. In the harsh conditions of the wild, any disregard for the body's signals could easily lead to fatal consequences. They regarded the ability to calmly analyze their physical discomfort as one of the most complex analytical skills. The elders would share their sensations around the evening campfire, comparing them with visual signs in the evening sky. If all internal and external indicators fully matched, the tribe would decide to make urgent preparations for the coming storm. Modern medicine confirms that tiny baroreceptors in our blood vessels also detect changes in the external environment. A drop in atmospheric pressure can cause changes in vascular tone, mild dizziness, and a general feeling of heaviness. For people living in constant harmony with nature, these subtle signals were not drowned out by constant urban noise. They were able to expertly isolate the necessary barometric information from the general, everyday background of physical sensations. This finely tuned nervous system was shaped by long years of hard life under the open steppe sky. The use of one's own human body as the most sophisticated instrument for measuring the surrounding world is striking in its effectiveness. A person acted as an ideal biological sensor, continuously recording the thermodynamic shifts of the heavy atmosphere. This unique knowledge erased any boundary between human biology and climatology, uniting them into a single system. Internal biological forecasts were just as critically important as observing clouds or wind direction. The deep interconnection between a living, breathing organism and the vast ocean of air manifested itself in every aspect of their lives. The scientifically proven fact that atmospheric physics directly controls the hidden mechanics of our joints is simply astonishing. Do you know what other hidden physiological signals our bodies send us before a sudden change in the weather? In the next chapter, you'll learn how high-voltage static electricity and low-frequency sounds influence the behavior of the inhabitants of the Native American camp. Are you ready to continue our fascinating historical journey into the incredible world of ancient and wise meteorology? Keep reading to the next chapter to find out how they coped with that terrible weather. The behavior of the Lakota's faithful four-legged companions in the camp was another absolutely reliable indicator of atmospheric changes. Long before the first heavy claps of thunder, the air above the plains becomes saturated with a huge amount of invisible static electricity. The friction of the massive masses of ice and water in the thunderclouds constantly generates extremely powerful, dangerous electromagnetic fields. These fields affect the thick fur, causing an extremely unpleasant tingling sensation and discomfort among the camp's inhabitants. The camp's inhabitants suddenly became very restless, frantically sought shelter, and tried to press themselves as tightly as possible against the ground. Thick fur possesses an amazing physical ability to quickly accumulate a static charge, especially in the dry climate of the Great Plains. The approach of a powerful thunderstorm front caused the hairs to literally stand on end due to the enormous difference in electrical potentials. This microscopic yet constant physical process caused quite noticeable discomfort to their sensitive nervous systems. The Indians observed these strange, abrupt changes in the usual behavior of their campmates with incredible attention. Unprovoked restlessness and anxiety in the settlement were always regarded as the final, most reliable warning of an imminent natural disaster. The second most important factor was a unique biological ability to perceive low-frequency infrasound inaudible to the human ear. Powerful hurricanes and severe thunderstorms generate low-frequency acoustic waves many hundreds of kilometers from their destructive epicenter. A keen sense of smell also played an indispensable role in this extremely complex mechanism of biological weather forecasting. The smell of heavy ozone, which we discussed in detail earlier, was perceived by sensitive receptors much more acutely and quickly. In addition, a sudden change in pressure forced heavy soil gases and the odors of underground cold waters out of the porous earth. This powerful concentration of chemical signals created an incredibly dense informational background for all inhabitants of the prairies. The combination of acoustic, electrical, and chemical stimuli always provided a 100% accurate and infallible forecast. The study of these complex behavioral responses demonstrates just how closely biology is linked to atmospheric physics. The nervous system acts as a perfect, hypersensitive oscilloscope, continuously recording the electromagnetic oscillations of the environment. The Lakota had absolutely no need for complex instruments, having such perfect and sensitive biological assistance at their disposal. Their symbiosis with the harsh natural world was always based on an incredibly deep understanding of these hidden mechanisms of physical interaction. Their keen observation and rigorous logic completely replaced entire modern scientific and research meteorological institutes for them. Today, science fully and thoroughly confirms the hidden mechanisms by which infrasound and static electricity affect the nervous system. We create complex, multi-million-dollar early warning systems for earthquakes and tsunamis, using similar physical principles. But many millennia ago, Native Americans had already mastered this technology in its original biological form. They were astonishingly skilled at reading the book of nature, not overlooking a single detail, no matter how small. Their forecasting methods remain forever an unsurpassed masterpiece of pure empirical science of survival in extreme conditions. Human synchronization with the harsh environment of the Great Plains reached its absolute unsurpassed peak. High intelligence and keen observation transformed absolutely every element of the surrounding world into a highly useful, life-saving tool. The complex physics of the atmosphere ceased to be a mystery, becoming an entirely understandable, logical, and predictable process. This knowledge allowed the tribes not merely to survive with difficulty, but to thrive successfully in the continent's extreme conditions. The ancient lessons of the past continue to genuinely amaze us with their cold rationality and mathematical, flawless precision. The ability to read the most complex cloud formations was a basic, essential skill for every adult Lakota Indian. The exact shape, height, and color of clouds are a direct, clear visual representation of thermodynamic processes in the invisible atmosphere. Huge cumulonimbus clouds, shaped like giant anvils, always indicated incredibly powerful convection of air masses. The violent collision of cold and warm air forces the accumulated moisture to rise rapidly, forming an icy flat summit. This heavy, icy cap, elongated in the direction of the upper-level wind, infallibly predicted a destructive storm. The complex color of the entire cloud system depended directly on the concentration of water droplets and the angle of the sun's rays. Black, incredibly heavy, leaden clouds absorbed almost all the incoming light due to the enormous amount of large, accumulated moisture. The ominous greenish tint at the very bottom of the massive thundercloud was the most terrifying visual warning. It arises from the refraction of light in dense ice formations and often precedes the formation of a tornado or large hail. At the sight of such green clouds, the huge camp immediately, in a panic, sought safe shelter in deep depressions or ravines. During the long period of severe summer drought, rare white cumulus clouds served as excellent indicators of rising thermal currents. They formed only where the air, heated by the ground, rose high enough for the scarce moisture to condense. The trailblazers skillfully used them to assess temperature patterns over the vast, sun-scorched stretches of the prairie. The dissipation of these rare clouds by evening was a clear sign of a stable high-pressure system and the continuation of hot, dry weather. This visual information was critical for locating scarce water sources and planning long routes. In winter, cloud observation was greatly complicated by the generally gray, monotonous, and gloomy backdrop of an overcast sky. However, the appearance of dark, almost black bands against the backdrop of a white blanket of snow always foreshadowed a sharp intensification of snowfall. These dark bands represented high-altitude zones of the most intense, large-scale crystallization of moisture in the troposphere. The indigenous people were exceptionally skilled at recognizing these subtle textural differences, even in conditions of extremely poor visibility. Their incredibly sharp vision was adapted to detecting microscopic contrasts in the monochromatic, blinding winter landscape. Correlating cloud shapes with changes in barometric pressure and heavy odors yielded a flawless, 100% accurate result. No modern supercomputer could process this entire array of visual data faster or more accurately. The empirical, hard-won experience of generations unfailingly shaped decision-making algorithms in extreme climatic conditions. The survival of the entire tribe depended directly on the correct, instantaneous classification of every cloud on the vast horizon. This science tolerated no approximation, always demanding surgical, mathematical precision of analysis from the observer. Today, clouds are meticulously studied using laser radars, satellites, and high-altitude weather probes. But the basic physical principles of their formation remain exactly the same as they were many hundreds of years ago. The Lakota read this incredible aerial architecture with the grace and understanding of natural-born physicists and climatologists. Their unique ability to integrate disparate visual data into a unified forecasting system impresses the minds of scientists. The vast sky over the Great Plains was for them the most honest, open, and informative encyclopedia of nature. The presence or complete absence of clear morning dew on the grass was the most important indicator of local weather on the plains. Cold dew forms en masse when the ground cools very quickly at night, releasing the heat accumulated during the hot day. Invisible moisture from the lower layers of the air rapidly condenses on the cool surfaces of the steppe plants. This strict thermodynamic process is possible only under a completely clear sky and in the complete absence of strong winds. For the observant Lakota, abundant dew in the early morning was a sure sign that the coming day would be sunny and calm. If, however, the grass remained completely, alarmingly dry at dawn, this served as a very serious cause for grave concern. The complete absence of condensation meant that the night sky had been thickly veiled by an invisible layer of heavy clouds. These clouds acted like a huge thermal blanket, simply preventing the ground from cooling down to the required dew point. In addition, strong night winds could mix the layers of air, preventing local moisture accumulation near the ground. Both of these physical factors strongly indicated the presence of an active, destructive cyclone in the region. A careful assessment of the time it took for the dew to evaporate provided information about the intensity of solar radiation and the density of the dry air. The very rapid drying of the grass in the morning sun was a clear sign of extremely dry, parched air. This greatly increased the risk of terrible steppe fires, requiring special caution when handling campfires. Extremely slow evaporation indicated high absolute humidity, which always preceded prolonged, dreary rains. All this complex climatic physics was deeply woven into the daily, arduous life of the proud nomadic people. Even in the harshest winter months, studying the frost on the branches of sparse trees yielded invaluable insights. Needle-like ice crystals, growing strictly against the direction of the wind, revealed the movement vector of heavy, moist air masses. The structure of the ice depended entirely on the rate at which supercooled water droplets froze in the frosty air. Large, perfectly transparent crystals formed only during a very slow, gradual cooling. Fine, completely opaque white frost was the result of a sudden, shock-like drop in temperature below zero. Daily observations of these microscopic phenomena required truly immense patience and incredible attentiveness. The scouts carefully examined every centimeter of the frozen ground around the camp, gathering data bit by bit for their forecast. Changes in the physical state of plain water served as their most reliable thermometer and accurate hygrometer. Water's ability to transition from a gaseous state to liquid and solid became the key to understanding the climate. Through years of practice, the Lakota mastered the interpretation of these complex phase transitions with absolute precision. A deep study of the interaction between the warm earth and the cold atmosphere demonstrates the Native Americans' systematic approach to meteorology. They understood perfectly well that the weather is formed not only high in the sky, but also at the very boundary between two different environments. The surface of the Great Plains functioned as a giant natural radiator, continuously absorbing and releasing solar energy. The ability to measure this invisible heat exchange through water droplets is a true triumph of empirical knowledge. Their unique survival methods were based on a complete harmony with the strict laws of natural thermodynamics. Modern weather stations use electronic humidity sensors based entirely on the same principles of condensation. But many centuries ago, the main tools were ordinary prairie grass and vast human experience. The striking accuracy of the Lakota's predictions saved many generations from certain freezing and terrible famine. A detailed study of their legacy reveals an incredible depth of understanding of the laws of physics without formulas or calculations. This is the most vivid example of how true survival science is born from complete harmony with the environment. The behavior of smoke from numerous campfires served as an absolutely reliable and visual barometer for the entire tribe. The strict physics of the dispersion of hot smoke gases directly depends on the density of the surrounding air. In clear, frosty weather, High atmospheric pressure always creates a very dense, heavy environment. Hot smoke, being significantly less dense, rises rapidly and perfectly straight upward. This column of smoke, straight as a taut arrow, was the best visual confirmation of a stable and safe high-pressure system. When a powerful storm front approaches, air pressure near the ground begins to drop very rapidly. The surrounding environment becomes less dense, and its aerodynamic lift decreases significantly and sharply. The hot gases from the fire cool very quickly, losing their thermal energy in the colder environment. As a result, the smoke cannot break through the heavy layers of moist air and begins to creep and spread along the ground. For the Lakota, this thick, creeping smoke was a signal of immediate alarm and a call to prepare for a safe shelter. The rate at which the smoke column changed shape accurately indicated the dynamics of the falling barometric pressure. If a perfectly straight column suddenly began to bend sharply and press against the grass, the front was moving alarmingly fast. The Indians coolly assessed this complex aerodynamic picture to calculate, down to the minute, the time until the squall began. Gusts of invisible wind in the upper layers also severely distorted the shape of the smoke, warning of dangerous turbulence. Even while inside the teepee, one could unerringly determine the state of the atmosphere outside simply by the draft from the hearth. In winter, thick smoke from the vast number of fires in the large camp created a local temperature inversion. Warm air accumulated directly beneath a layer of icy cold air, forming a peculiar smoke dome over the settlement. If this protective dome suddenly and rapidly collapsed, it signaled the imminent arrival of the Arctic front. Observing the camp's overall aerodynamics provided a macroscopic, large-scale picture of high-altitude atmospheric processes. The Indians thought on a grand scale, assessing the interaction of the entire biosphere with the gigantic, invisible ocean of air. The ability to correctly interpret smoke was passed down to children from a very early age as a basic survival skill. From a young age, they learned to understand that invisible air possesses immense weight, density, and colossal force. This applied, practical physics shaped a very rational and incredibly attentive view of the surrounding world. The complete absence of complex instruments was more than compensated for by an absolute, intuitive understanding of gas mechanics. Smoke from a campfire was their universal, reliable sensor, operating around the clock without the slightest glitch. Cross-referencing data from the campfire with the behavior of the prairie animals and the color of the sunset yielded a flawless forecast. The Lakota had created a simply ideal, foolproof system for cross-checking all meteorological data. If all physical, chemical, and optical signs unanimously pointed to a storm, there was no room for doubt. The vast tribe functioned as a single, coordinated mechanism, strictly obeying the iron logic of natural laws. Their successful survival strategy was entirely based on a sincere respect for the power of the elements and a deep understanding of them. The traditional weather forecasting methods of Native Americans still amaze with their scientific validity. They prove to the whole world that a profound understanding of thermodynamics is possible even without a complex academic education. Incredible attention to detail and rigorous systematic analysis have saved this people for many centuries. Their unique legacy teaches us to be more attentive to the invisible processes that surround us every day. Atmospheric physics is accessible to anyone who knows how to observe carefully and draw correct, logical conclusions. We have examined in detail the complex, multifaceted weather forecasting system of the indigenous peoples of the Great Plains. These methods provide compelling evidence that the Lakota possess profound knowledge of atmospheric physics, aerodynamics, and optics. Without satellites or radar, they read the weather through invisible vibrations, smells, and optical illusions. What other unique Native American survival skills do you think we should cover in detail? Suggest topics for future videos you'd like to see on our channel in the comments, and be sure to subscribe so you don't miss new historical episodes.